Hello everyone, welcome back to my channel. So today we are going to see another very important problem, that is merge two sorted arrays without using extra space. Without wasting any time, let's get into the video and see how this can be solved. So this is the problem which we are going to solve today. It says merge without extra space. Let's quickly go through this problem. It says, given two sorted arrays, array 1 and array 2 of size n and m in non-decreasing order. So if we see the example 1, so we are given two arrays which are sorted in non-decreasing order, that is ascending order. Okay. So now merge them in sorted order without using an extra space. What does it mean is we don't have to use any extra space over here, any extra array or any other extra data structure. Okay, we need to sort the array in such a way that we don't use an extra space and only use the space which is provided to us, that is of array 1 and array 2. That's it. Okay, so the next line says modify array 1 so that it contains the first n elements and modify array 2 so that it contains the last n elements. Okay, so the least first elements should be contained in array 1 and the largest of the elements in both the arrays should be contained in array 2. I repeat, the smallest of all the elements of array 1 and array 2 should be contained in array 1 and the largest of all the elements in array 1 and array 2 should be contained in array 2. Okay. Suppose we are allowed to merge these two arrays in sorted order with using extra space. How are you going to do that? Just think, pause this video and think a bit. We can do that by using an extra array. That extra array will have the size combined of both the given arrays, that is 4 plus 5 over here, that is the extra array which we are going to take will have the size 9. Okay, and then we'll keep all the elements of array 1 into that array and then all the elements of array 2 into that array and simply sort that array. So we have merged both the arrays, both the given arrays into a single array. Okay, so but here the requirement is without using extra space. So let's get into the video and see now how can we do that. Don't worry, I am going to dry run everything and explain everything. So let's get started. I have taken the same example which we were referring earlier. Over here we are going to use a two-pointer approach. The first pointer is going to point to the last element of array 1 and the second pointer is going to point to the first element of array 2. And what we have already discussed is array 1 should contain all the smallest elements. Okay, just keep that in mind. Okay, so now let's P1 be the pointer which is pointing to the last element of array 1 and let P2 be the pointer which is pointing to the first element of array 2. Okay, so now just compare if the value which is pointed by P1 is greater than the value which is pointed by P2. If it is greater, then we need to swap. Why? Because array 1 should contain all the smallest elements, right? So on swapping, what will we be getting? We will get 1, 3, 5, 0. And the second array becomes 7, 2, 6, 8, 9. Okay. So now the P1 pointer is going to decrement and P2 pointer is going to increment. Again, we need to compare. If the value which is pointed by P1 is greater than the value pointed by P2, yes, it is greater. So again, we need to swap. On swapping, array 1 becomes 1320 and array 2 becomes 75689. Again, the P1 pointer is going to decrement and the P2 pointer is going to increment. Okay, so now again we need to compare. So the value pointed by P1 in this case is not greater than the value which is pointed by P2. So at this point we need to just stop. Okay, we need to just stop. Over here we can see that array 1 is containing all the smallest elements of the 9 elements and array 2 is containing all the largest elements of the 9 elements. Right? But these are not sorted. Right? So we can run a sort on the first array as well as on the second array. So on running the sort on the first array, it will become 0, 1, 2, 3. And on running a sort on the second array, it will become 5, 6, 7, 8 and 9. So this is what is needed. Regarding the termination condition, we need to keep 3 things in mind. First of all, if we find that P1 is pointing to a value which is less than the value which is pointed by P2, we need to terminate. Second point is that if P1 is pointing to an index which is less than 0, then we need to terminate. And the third thing is that if P2 is pointing to a value which is greater than M, that is M minus 1, okay, so then we need to terminate. Okay, you need to understand this. Take your time, see this recording once again, this part of the recording once again if you want. So let's head towards the algorithm and then we'll see the program for this. Let's see the algorithm now. Over here we are going to take 2 pointers. So we need to initialize the first pointer with the last index of the first array. Let's take it as P1 and we need to initialize the second pointer with the first index of the second array which is 0, and let's take it as P2. Okay, so now we need to run a while loop until the following 3 conditions are satisfied. What are the conditions? As we have already discussed, that is P1 should be greater than or equal to 0 and P2 should be less than the length of the array 2 and P1 should be pointing to a value which is greater than the value which is pointed by P2. Fine. So now if all the following 3 conditions are met, then what we need to do, we need to swap the values. Okay. So if all the 3 conditions are met, which is P1 is greater than equal to 0, if P2 is less than the length of the array 2, and if P1 is pointing to a value which is greater than the value which is pointed by P2, then we need to swap the values which is pointed by P1 and P2 and we need to decrement P1 and increment P2. Fine. If any of the above conditions are not met, what we need to do, the control automatically comes out of the loop and then we need to sort both the arrays and we are done. This is the algorithm. Now let's see the code for this. Now let's start coding the solution. Remember that we are going to follow our algorithm step by step. So the first step is we need to take two pointers, be it P1 and P2. Now we need to initialize the first pointer with the last index of the first array, which is n minus 1. And we need to initialize the second pointer with the first index of the second array, which is 0. Okay. So now what we need to do, we need to take a while loop and we need to keep the following three conditions over here. What P1 is greater than or equal to 0 and P2 is less than P2 is less than m, and the third condition is the value which is pointed by P1 should be greater than the value which is pointed by P2. So what we can keep it? We can keep it array 1 of P1 is greater than array 2 of P2. Okay, so we are done with all our three conditions. Now, if all these three conditions are met, what do we need to do? Then we need to swap the values, right? We are taking long over here because both the arrays are of long type and not of integer type. So we are taking it as T and we are going to write the swap code, which is very easy. First, we are going to keep the value which is pointed by P1 in T. Then we are going to keep the value which is pointed by P2 in the place which is pointed by P1. And now we need to keep the value which we stored in T in the place which is pointed by P2. Okay, now we need to decrement P1 pointer and we need to increment P2 pointer. Okay, so once it comes out of the loop or once any of these conditions are not satisfied, it will come out of the loop and then we need to sort both the arrays. So we can use this predefined function for sorting, which is arrays.sort. And we are done. Let's start compiling and running the code. It's running and it has completed successfully. So now let's try submitting this code. It has been submitted successfully. I hope you understood this video. If you did, don't forget to like this video and subscribe to this channel. If you have any doubts, do let me know in the comment section below. And see you all in the next video. Until then, keep programming. Bye-bye.